नाम तो मेरा भी दिया है। दो लोग जाएंगे जी। Morning, everyone. Here we are going to discuss the our topic for GKGS, which we were discussing in previous classes. So we will continue from there only. Last time we have completed till the heating effect of current, and those were the last topic, electric power. That was electricity. In physics, only the I think only in syllabus. If we look at it, then we find only one chapter is like topic is left, that is magnetic effect and current. So sometimes one two question comes from this chapter also. So we will discuss this, then further we will move to the chemistry part. So today's topic is magnetic magnetic effect of electric current. So the discovery has made by the discovery of magnetic current and electric effect was done by Hans Hans Christian Oersted. He has done this discovered it in 1820, and discovery of the heating current of magnetic effect, that was done by heating effect of electric current. This is also a phenomena we find in the when electricity passes through any conductor. That was done by the James Joule in 1850. So how this usually occurs? How they have discovered this? Like they have taken one compass, and there was a one compass in which the one needle is there was there, and the electricity was passing near to it in a box format like this. It was a conductor which they placed. When they have passed the electricity through it, then what they have observed at that time, the needle of compass was deflected. When electricity passes at that time, the needle of compass was deflected. So direction of magnetic uh, field and direction of magnetic field changes due to change in current, due to change in direction of current. So this was the phenomena they have uh, witnessed, and after that they they discovered the effect of uh, magnetic effect of current and electricity. And now we will magnetic field. We know that in magnetic field there are two poles in a magnet like this. This is a magnet. In this there are two poles, is north and south. We know that same poles repel each other, and different poles repel or, or attract each other. And in this magnet, we know that the magnetic field lines originate from North Pole and they go to the South Pole outside the magnet. But in case of inside, they originate from South and go to the North. Magnetic originate North Pole and terminate at South outside the magnet. But inside they go from South inside South to North like this. We know that magnetic field lines never intersect each other. What? Never intersect. Therefore, they have only one direction. they have one direction. In this case, if the magnetic field lines are closer, sorry, in this case, if magnetic field lines are closer, they're more closer, then the magnetic field will be also the magnitude of magnetic field of is more when magnetic field are closer, then magnetic field also more. Now we study the magnetic field due to current carrying conductor. In this phenomena, the magnetic field is inversely proportional to distance between the current carrying loop. What does it mean when magnetic field is de- when magnetic field will increase when we decrease the distance when we come closer, and but it is directly proportional to current. When direction of current changes, then direction of magnetic field also changes. Now we will know about the Maxwell's right hand thumb rule. Maxwell's right hand. We need to remember this phenomena like this. If we draw, there is one magnetic rod. If this is the magnetic rod, and the current flowing through it in upward, this is the current and the magnetic field will be around this, like this. So in this figure, when current, we need to remember when current flow upward, what right hand thumb rule states, then then the magnetic field will be in anti-clockwise, like this. Then magnetic field is in anti-clockwise. And when current flow downward, then magnetic field will be in clockwise direction. In same one another concept has given by the Maxwell. This is the Maxwell right hand thumb rule, and another that was magnetic Maxwell's screw rule. In Maxwell's screw rule, like this, is the screw. If current flow in clockwise direction, then current will be downward. This is the current. So in this case, when we rotate this screw, when it goes to south, then the pole is constructed. When we rotate in clockwise, then south pole is it behaves like south pole in clockwise direction. When north pole, when it is anti-clockwise. When we rotate in anti-clockwise. So whenever we make any current carrying conductor in which like in which if we increase the number of turns of loop, that current, like it is if it is a current carrying loop, if we increase the number of turn of this loop of current carrying conductor, then the magnetic field will increase. So number of turn is directly turn in loop increases, then magnetic field increases. If distance is increases, then we know that if the distance between them increases, then the magnetic field will decrease. If the current of this is increases, then the magnetic field will also increase. So these are the phenomena we should remember. We should know about the magnetic field. And one solenoid concept of magnetic field. When we take a war magnet, when we take any solenoid means it is a conductor, and it is a like it's a rod, it's iron rod, and we when we wrap it like this with current carrying loop, at that time, if we flow the charge from there, then what this the solenoid behave like? This behave like a war magnet. This behave like a war magnet. This behave like a war magnet, and the magnetic field is maximum inside the solenoid. But in this case, if the magnetic field is the current is flowing in this direction like this, then the direction of current is reverse the direction of magnetic field. But outside this solenoid, the magnetic field is equal to zero. Outside, we consider it equal to zero. But inside, it's a maximum. So, if we what phenomena we come to know about the electric current, if we take any iron rod and if we flow the charge, if we pass a current through it, like this is the iron rod, we pass the current through it, then the phenomena which we come to know it, this behave like a magnet. This is called the magnet. Hmm. Now we should also study a current carrying conductor behavior. It was force on a current carrying in a magnetic field. So if the current is passes like this is the magnet. If the current is passing like this. Like this is the direction of current. If this is the direction of current, and then this will be the direction of magnetic field. So this is the Fleming left hand rule. This is called Fleming's left hand rule. On this principle, what works? The motor works. Motor, motor, like it changes electric energy into mechanical, because when motors rotates, when motors inside the current is rotates, then the magnet is there and it starts rotating. It's in that which it changes the mechanical energy. In this case, when the force is maximum, when force is maximum at 90 degree. At 90 degree, the angle between conductor and magnetic field. In minimum at 0 degree. This is the like this. When this magnetic field is going like this, and this is the current. So this is making 90 degree angle. So the force is maximum. So this will start rotating like this, like this, and minimum at 0 degree. It will be parallel. We are going to know about few things, important points. The coil of wire in a electric room heater is known as what we know that it is known as element. Michael Faraday great scientist. He gave the concept of electric field for the first time. Some few topics and few the concept from which the questions may come. So I have revised all the concept of magnetic important concept of magnetic field and current. It moves from always north to south, outside, inside, south to north, and like when the distance is inversely proportional to distance, when the current is maximum, then there will be maximum magnetic field. हाँ हाँ हेलो हाँ चल रहा हूँ चल रही है चल रही है ठीक है चल रहा हूँ आजा तू किधर है ठीक है मैं आ रहा हूँ फिर हाँ so today I am going to end this class uh, because of some urgent work. I will discuss further topics in next classes.